Welcome to lesson 7.1, day 1. The learning target for today's part is to be able to analyze and graph parabolas. Parabolas are not strange to you or brand new to you because you graphed them when you graphed quadratic functions in the form y equals ax squared plus bx plus c, or in the form, vertex form, y equals a times x minus h squared plus k, vertex form. We're going to be looking at them from the conic section standpoint, where we're looking at the standard form. However, because we're looking at them as conic sections, we're not just looking at them as y being dependent on x, where it opens up or down, which is still possible. We're also looking at where x can be dependent on y, where it opens to the right or left. So a parabola represents the locus of points in a plane that are equidistant from a fixed point called the focus. The locus of all points equidistant from the focus. And a specific line called the Directrix. So we're just going to put and direct and the Directrix. There's the definition of a parabola. The locus of all points equidistant from the focus and the Directrix. We're going to look at the standard form of this equation. The standard form of this equation, when it opens left and right, is we have, I like to do it on this side, 4p times x minus h equals y minus k squared. Your book and other guides will put the y minus k squared first. If it is the y that's squared, now think about this. If you're used to seeing the x squared and the y not squared, that's when you know it opens up and down. If you see the y term being squared, that means it's opening right or left. Whereas if you see the x term being squared, so we have 4 times p by y minus k equals x minus h quantity squared. If you see the x being squared, then it opens up or down, just like when we graph regular old quadratics where the single y is dependent on x, which happens to be squared, making it a quadratic. The vertex for both of these, very simple, is h comma k. Right here, here's our vertex, our h comma k. Now what is p, you may ask? You see p in this formula. P is the distance from the vertex to the focus. Vertex to focus is the distance of p, and vertex to Directrix is the opposite of p. So the distance from here to the focus and the distance from here to this dashed line called the Directrix, that's a distance of p. Our axis of symmetry for a horizontal one opening horizontally, its axis of symmetry will be a horizontal line, y equals, and it'll be y equals k. For a one that opens vertically, it'll be a vertical line, x equals h. To find the distance from the vertex to the focus, we're going to have, I said it was from the vertex. In this case, this opens to the right or the left, but p will be negative if it's to the left. So it'll be, since it's opening to the right, h plus p. It's going to change, p is going to change the x coordinate of the vertex for it to open left and right. And the Directrix will be y equals k minus p. We'll see some examples of this in a second. For this one, the focus is going to be h comma k plus p. We do, to get the focus, remember it is the vertex plus p. To get the directrix, it's the vertex minus p. So in this case, it's opening up and it's changing the y coordinate. I wrote this one down wrong, sorry. This one should have been x equals k minus p. It has to be a vertical line if it's opening to the right or left. This one should be y equals k minus p. It's the x that changes when it opens left and right. It's the y that changes when it opens up or down. So this is opening left or right, opening up or down. It's the y that changes. All right, so let's take a look. For each equation, we're asked to identify the vertex, focus, axis of symmetry, and directrix, and then sketch a graph. For letter A, it is the y term that is squared. Remember that when it is the x term that is squared, it's going to be opening up and down. That's what we're used to seeing, but it's the y term that's squared, so I know that this opens either left or right, and we're going to figure that out in just a second. So my vertex for this is x coordinate first, then y, 2 comma negative 5. I'm going to plot that on my graph. 2 comma negative 1, 2, 3, 4, 5. 2, negative 5 is my vertex. All right. Now, the value of p, this is 4p. 4p equals negative 12. So this means when I divide by 4, p equals negative 3. Since p is negative, it opens to the left. If p were positive, it would open to the right. To find my axis of symmetry, it's going to be y equals k. So in this case, y equals negative 5. To find my focus, it's going to be the vertex plus p, but it's opening to the left. So I have to do 2 plus negative 3. This gives me negative 1 comma negative 5. So let's look at that. Our axis of symmetry has to be y equals negative 5. So here's my axis of symmetry. My focus has to be negative 1, negative 5. That's definitely going to open to the left because the vertex opens around the focus. And lastly, our directrix is going to change the x as well, but it's vertex minus p. So I have 2 minus negative 3, which is negative 5. X equals negative 5. So there's 1, 2, 3, 4, wait, I'm sorry, positive 5. 2 minus negative 3 is positive 5. So there's 1, 2, 3, 4, 5. It's going to be this vertical line. So now I should see a distance of 3 to the directrix, a distance of 3 to the focus. They're equally distant from the vertex. And my parabola will open toward the focus, away from the directrix. Let's take a look at another example. Letter B has the equation where x is squared. So when I see that x is squared, that means it's going to open up or down. We'll know when we look at the value of 4p. 4p equals 8. So that means that p equals 2. Since p is positive, this one's going to open upward. My vertex for this, again, we do the x and then the y, 4 comma negative 3. So I'm going to graph that. 1, 2, 3, 4, 1, 2, 3. There's my vertex. My axis of symmetry will be the vertical line that goes through that. That'll be x equals 4. My focus is my vertex plus p, except it's the y coordinate that's changing. So I have negative 3 plus 2, which is negative 1. So 4 comma negative 1. Wait. I plotted it in the wrong spot. It's totally my fault. Vertex should not have been up there. It should have been at 4, negative 1, 2, 3. And now my focus is at 4, negative 1. That makes a lot more sense because it's going to open upward around the focus. Our Directrix is the vertex minus P. And again, since it's opening up and down, that's going to change the Y value. It's going to be negative 1 minus 2, which is Y equals negative 3. So I go down negative 1, 2, wait, I looked at the focus, sorry. It was negative 3 for the vertex, minus P, which is minus 2. Negative 3 minus 2 is negative 5. Y equals negative 5. 1, 2, 3, 4, 5. There's my Directrix. There's my focus. They should both be 2 units away from my vertex. And this graph opens up from the vertex around the focus. Up from the vertex around the focus. Looking at letter C, you should immediately know which way it's going to open. It is the Y value that is squared. Since the Y value is squared, that's going to open either left or right. Look at the value of P. 4P equals 2. So that means that P equals 1/2. Since it's positive 1/2, it's going to open to the right. When we graph this, we expect to see it opening to the right. Our vertex is negative 6, negative 1. 1, 2, 3, 4, 5, 6. Negative 1 would be right here. Yep. And then our axis of symmetry will be a y equals equation, y equals negative 1. Go right through our vertex and cut our parabola in half. We're expecting this parabola to open to the right. And so this will cut that parabola perfectly in half. Our focus is the vertex plus P. It'll be the x of the vertex plus P. So negative 6 plus 1/2 will be negative 5.5. So negative 5.5. There's our focus right there. Our Directrix will be our vertex, which was changing the x-coordinate since it's opening left and right, minus P. So I have negative 6 minus 1/2, which is negative 6.5. X equals negative 6.5, which should be roughly here. So here's my Directrix. It's a half unit from the vertex. Here's my focus. It's a half unit from my vertex. My graph opens to the right around the focus, opposite direction of the Directrix. And that's how we graph parabolas. Writing equations in standard form is going to be a lot like ellipses and hyperbolas and circles. However, you only have one variable where you have to complete the square. And we also have to get the 4p. Let's look back. We don't want a coefficient on it like we have here. We want to get the coefficient on the squared value over here. We have to move it to this side to get it in front of the term that is not squared. So let's take a look at this. I'm going to start with y equals this. I need to factor out the 1/4 or the negative 1/4. We're not going to do it on this side. We're just going to do it on this side. Y equals negative 1/4. You know what? I don't even like that fraction to start. So I'm going to be lazy and multiply everything by negative 4. So I have negative 4y equals positive x squared minus 12x minus 6 times negative 4 is going to be negative 24. So here's what I have. I multiplied. I didn't want to deal with this denominator with completing the square. Lucky me, I don't have to for the parabola. I was able to multiply every one of these terms by negative 4. To complete the square, A is gone, makes completing the square very easy, except I also have to move this 24. So I'm going to add the 24 to the other side. I have negative y, 4y, plus 24 equals x squared minus 12x plus box. Whatever I add on this side, I'm going to have to add over here. B over 2 would be negative 6. Squared would be 36. So this completes the square, so we can factor it down to here. Put the 36 over here. 36 and 24 is 60. So right now I have negative 4y plus 60 on the right-hand side. Problem is, I have to have 4p, remember it has to be 4p times y minus k equals x minus h squared. That's the form I'm looking for. So I have to factor out the value, everything except for y minus k. Well, here's the y. That means I need to factor out negative 4 from this. That means I have negative 4 times y minus 15, because that would multiply to positive 60, equals x minus 6 squared. So the nice part about parabolas is we only have to do completing the square on one variable. We don't have to do it on two variables, like we did for the other conic sections. So again, I started by getting rid of this lead coefficient on x squared, moving it to the other side, made it a little bit easier to complete the square. I did have to move the constant over as well. Once I completed the square, I just had to factor out the greatest common factor to get a single y for the y minus k. Now I might be asked to graph this. The vertex would be 6, 15, and I could find the rest from there. Right now we're only asked to write the equation in standard form. This one has the y squared variable, so we know that for this particular problem it would open either left or right. We won't be sure till we have the equation in standard form. So I need my y's on one side and everything else on the other side. So I have 3y squared plus 6y equals, I'm going to add 12x and I'm going to subtract 15. Now if I want to, I can divide by 3. If it goes in evenly, it would make it much easier to get this. So I'm going to divide everything by 3. I now have y squared plus 2y equals, if I divide every term by 3, 4x minus 5. To complete the square, I have y squared plus 2y plus box equals 4x minus 5 plus box. B over 2 is 1, squared is 1. That makes this y plus 1 quantity squared. On this side we have 4x minus 4. And I need to factor out the 4 to give me x minus 1 so I can see the x coordinate of my vertex. And y plus 1 squared. This is the form the book would have. I prefer this to be on the left-hand side, but this is good. We now have, we can clearly see the vertex. We can see the value of 4p. P is the value of 1. The vertex is 1, negative 1. And we know it opens left and right because it's the y that's squared. This one will open right because p is positive. Last but not least, we have letter C. Hopefully you can see it already, but if not, this one is going to open up and down because x squared is the term. There's no other x term with it. Just need to move everything to the other side. So x squared, I'm going to add 4y to both sides and subtract 3. Lucky me, since there's no x term to pair with the x squared, I don't even have to complete the square for this problem. But I do still have to factor out the coefficient on, this isn't a p, this is a y. I do still have to factor out the coefficient on y, which is 4, giving us y plus 1. This would have a vertex of 0, negative 1. 4p equals 4 would give us a value of p of 1, and we could find all the parts from there, axis of symmetry, focus, and directrix, just like we did on the first part of these notes. This concludes the video notes for day 1, where the learning targets were to understand how to graph ones that open horizontally versus vertically using these formulas, and how to convert from this form to standard form, from general form to standard form. Have a great day.